Okay, so you've had some time, and this is not hard. So I hope this is what you have written. This is an open interval. Okay, what makes this open? Well, open basically means that the complement is closed. Well, that doesn't mean a whole lot, right? For our purposes, open just means that the endpoints are not included. Okay, there are a lot more important properties I have to tell you about open and closed sets, but they will come at a later date. Okay, for right now, think of an open set as something that does not include its boundary points. And then the interval, okay, interval from negative infinity to positive infinity. Well, what kind of an interval is that? Well, that's the whole set. In this case, it's a universal set of R, right? The set of all reals. So you really can't, do a very good job drawing the picture of this. It's basically the entire real line, but we denote it with this script R. Okay, so remember to use symbols like belonging to number 8, and then R, and then different sets of numbers such as rationals and the integers and so on. All right, now calculus, as you know, is a study of functions. In fact, one of my favorite professors undergraduate used to say mathematics, all of mathematics is a study of functions. That's so far I have found that to be fairly true. Okay, so when we say a function has the domain A and a codomain B, you are probably familiar with the word domain. It's a set of all elements of the input of the function. So that's you can sometimes draw a picture of a function like a box. This box is called f, a function. Something goes in. The thing that goes in is called an element of the domain, the set of all the elements that go in the input set, the input values. That set is called the domain. And then what comes out is very specific to x, and f does a very specific task, whether it's squaring x or adding x or adding 1 to an x, or take the inverse of x, whatever. And what comes out is called the f of x. The set of all of these is called the range. Okay, so what in the world is the codomain? Well, sometimes this is really hard. It's hard to find the range, but we know what kind of things they are. Okay, so for instance, when you square a function, what comes out is all the, this could be all of the real numbers, but what comes out is restricted to positive numbers and 0, right? The set of non-negative numbers is the range, but sometimes we don't know depending on what the function is. But we do know that all of these are going to be real numbers. We just don't know what portion of the real numbers would constitute the range. So instead, we just talk about the codomain. Codomain is, in this case, an R, right? The set of all reals. The range happens to be the set of non-negative reals. Okay, but if you don't know that, we can say the codomain is the set of real numbers, because we know that everything that comes out will be a real number. Okay, so this is the notation. We use this F and the colon and then A to B. And so that is, and the first letter here, this is the set, which is the domain, and the codomain is written as a symbol, usually a capital letter after the arrow. All right. Quickly, number 14, the function f is the cosine function. So you write f of x is cosine of x, right? That's the mathematical translation of the English sentence that you see here under 14. Right? So that is a long sentence. Well, it's not a long sentence in English, but it's much more concise when you write in mathematics, in the language of mathematics. Now, by the way, what's the domain of this function? Yeah, x could be anything. Okay, we're using radians, of course, and x could be, negative 3,000, and x could be 0, x could be pi, x could be square root of 17, whatever, right? X can be anything. And what's the codomain? Again, it is a real valued function. The answer is always going to be a real function, a real number. So you can say the codomain is the set of all real numbers. So this is called a real valued function. Okay, and so and that's precisely because the codomain is a set of real numbers. Okay, the cosine of x is not going to be a dog or a fish or a house or whatever, right? I mean, it's going to be a real number, and that's what we mean by a real valued function. This is significant because in calculus 3, unlike in other classes of calculus, we are going to be talking about not just real valued functions, but other things like vector valued functions and vector field valued functions and so on. By the way, the range in this case is actually pretty simple. Okay, you just happen to know the range of this particular function, the cosine of x, which is what? From -1 to +1, including the endpoints, right? So this is the closed set from -1 to 1. Okay, now here's a function. That's a polynomial function because you don't have x square root of x or 1 over x or anything. It's a 4th degree polynomial. This is a real valued function defined on the reals. So this on the reals, this is the domain. So that means f goes from R to what? Real valued function, right? If it's a real valued function, then it has to go to R. And you say, well, 14 and 15 look exactly the same. F goes from R to R. Right, because they are both real valued functions on the reals. You know what this graph looks like, by the way? You don't. You really don't? That's okay, because I don't either. Okay, now, I have some clues. Okay, we know things about polynomial functions. It's a 4th degree. The leading coefficient is positive, which means the graph will go either look like this or maybe up and down like this. You can have up to 3 critical points, right? So the graph will look like this. It doesn't go like that, okay? Because as x goes to infinity, the function does go to infinity. So this is not going to look like this. All right, but the problem is there will be a minimum value here, whatever that is. Okay, you don't know what the range is, right? I mean, do you know what the range of this thing is? Well, yeah, if you do calculus, you can figure out the absolute minimum, but right now, you don't know what the minimum value is, and therefore, you don't know what the range is. Okay? Many times, it doesn't matter what the range is, as long as we know that the value will always be in the real number set. And that's why we use the word codomain as opposed to the range, which is sometimes hard to find. Okay, so let's look at some of the examples here. Okay, you can create your own exercises here, or you can come up with your own answers here. The functions from the reals to reals. We know a lot of functions here. You know, y is equal to x. That's certainly a function. The real valued function on the reals. X squared, x cubed, any combinations, you know, all polynomials are of this first type. You can also have something like sine of x, cosine of x. Now, I'm not going to put a tangent of x. Does anybody know why? Maybe I will just go ahead and put tangent of x. And then I will say no. Okay. Now, why not? Because the tangent of x does not have the set of real numbers as its domain. Okay. Bunch of numbers are missing because, for instance, at pi over 2 or 3 pi over 2, the tangent is not defined, right? So you can't say tangent goes from the reals to the reals. Natural log, is that okay? No, because the natural log, ln, is not defined for 0 or negative numbers. Now, this one is almost that. Okay, defined on all the reals except one number, namely 0, so we can't have that. But you could have e to the x, okay, and so on. All right, all of these functions, you have looked at these things and studied and spent many, many hours on these functions. Okay, these are of the first type. Now, you have functions that are defined only in the positive numbers to real valued function. The typical example here would be a natural log. Right. Oh, by the way, R plus is the set of reals, which are what? Yeah, basically from 0 to infinity. Okay, it's the set of all positive real numbers. Oh, I'm sorry. Yeah, it is a set of all positive real numbers. What am I saying? So therefore, I have to exclude 0, okay? And it has to be an open interval. All right, now in chapter 3, we'll be learning about these functions here. Let's say f of t could be something like cosine t, sine t. So this, you notice here, this is a very different, I mean, this is basically a parametric function that you have studied before. And you notice here the value is actually a point in a two-dimensional plane, right? And so this would actually be a circle, unit circle. You can also write this as x is cosine t, y is sine t. Right? T is called a parameter. This is called a parametric equation. It's also because the codomain is R2, we will call this a vector valued function. We'll be talking about vectors in a minute. You can add another component, the z component, and this will be a function from R to R3, right? And so that's also a possibility, right? We'll be studying these things in chapter 3, okay? Now, you have a few more problems here, 4 problems here, okay? Why don't you take a look at these and then try to come up with examples, right? And that's okay if you get them wrong, but I will come back to these in the next part of our video, and then we'll try to finish this. Okay, so go ahead and try to answer the next 4 questions. Give yourself a few minutes, and then go on to the second or the third part of our video for this lesson.